Describe the relationship between the line 132 plus s4 negative 1, 0 and the plane x plus 3z equals 7. So with the wording of the question, we could have an intersection point. Maybe this line is on the plane, or maybe they just sort of run parallel to each other and don't actually intersect. The way we'll approach this is the same regardless of what we think may or may not happen. We should still write out parametric form for our line. Okay. So the point we're given is 132. And then we get the coefficients for s as 4s and then minus s, and then there was a 0, so we don't really do anything there. And then our line is 3x plus z is 7, or not our line, our plane. Oh, sorry, x plus 3z equals 7. Had the coefficients in the wrong spots. Okay, so what we're going to do is we're going to take the equations for x. There's no y in the expression, but technically it's being plugged in, and z, and we will plug in and see if we can solve for a value for s. Okay, 1 plus 4s plus 6 is 7. 1 and 6 is 7, so 4s plus 7 is 7. 4s is 0, so s is 0. Okay, that's fantastic. That tells me right away there is a point of intersection. We need to remember how to interpret the end result. If you can solve for a value of s or t or q, you have a point of intersection. And to give a perfect answer, we would then plug this value of s back in. Say x is 1 plus 4 times 0. Y is 3 minus 0. And z is still going to be 2. Z is always going to be 2 for every point on this line. So we get 1, 3, and 2. So 1, 3, 2 is the point of intersection, or POI, as we tend to abbreviate it. Okay, so there was a point of intersection. That's the relationship between this line and this plane. The line comes across, and they do intersect at some point.